Well, hello there. Just thought we'd demonstrate the the principles behind the two-mass screen technology to show how that they're far more efficient with the amount of energy that they actually get in them. Now, this test rig was provided to iPut by General Kinematics, who are the best two-mass screen suppliers on the planet, if you don't know that by now. So what this is an exciter, which has got a rotating eccentric in there. It's variable speed by the potentiometer there. There's a compression spring which is magnetically coupled to for convenience of the test rig, to the exciter and this mass. It was originally actually provided with a lighter spring. I'll just show you what we've done there. We've collected a few other springs of different stiffnesses. Actually, the one that this test rig came with is the one on the right, and for reasons you'll see in a moment, we've actually got the next one next to it, which is about double the stiffness and not much different in length really, hooked up to it. So, okay, I know what you're thinking. Two mass screens, this is an exciter and that's equivalent level trough. I don't know if you can see that, it's 351 grams, this is 647, and we all know that the troughs are heavier than the exciters. So there it is. I thought that too. So, got into it. I've made a much heavier mass. Here we have Mr. 830. Oops. So that's a substantial amount more, and this is why we're using the stiffer spring, because the other one hits the bottom. Let's get that going. Oh, I've got this frequency set for the lighter mass, of course. Any minute now we'll have a demonstration of this one. Taking off. Ah, there we go. Okay, it's still putting a lot of energy into it. I didn't show with the other one, but I can attempt to stop it and it doesn't stop. There's still a lot of energy being produced by that. Even taking it out of the exciter, you still get quite a lot of energy being put into what's the equivalent of the trough section. I know we could get that a little bit even more if we're just guiding it. That's all I'm doing here, is guiding it so that it's staying vertical. But again, I thought, right, let's try and demonstrate a brute force equivalent. So I made up this adapter, and a true, like an initial reaction of a brute force would be this mass plus that mass, or maybe this mass plus that mass, because a brute force is not as heavy as the combined mass of a two-mass screen. But neither of those are a good representation, because, as I said, we just haven't got the energy in this eccentric. So what we can do is effectively increase the energy in the eccentric by completely removing all of the additional mass. So this is now, that's effectively the combined screen mass would be 647 instead of, you know, whatever that adds up to, rather a lot. And I know, because I've experimented with this, so it's a lighter system, so it should need more frequency to find some kind of resonance. And if I could swap to one of these other springs and get this thing going other than by me pushing it, I would. And honestly, it's just simply not got the energy in that eccentric to get this system vibrating. You know, and now I'm reaching the point of speeds which are just unrealistic, because they're not within a similar range. So that bouncing, and I'm a bit astonished at this, that we're not getting decent vibration out of it. So that just goes to show you how much energy is available from the two-mass screen or spring support system for a screen. So there you go. I hope you've learned something today. come back and we'll what we're going to do next. Oh, it doesn't matter. We'll delete this bit off the end of the video. That's what we'll do.